in our last class we discussed mainly the integrated rate equations for the zero order reaction. I hope you have understood, you have went through that derivation and understood it. Now we are going to derive the integrated equation for a first order reaction. The method of integration or the approach still remains the same. Only thing is that it is for a first order reaction. So what is basically a first order reaction? You might be knowing that here the reactants. Okay, here if you say look at the rate of the reaction, it will be proportional to what actually the first power of the concentration of the reactant. For example, if I can say, let me say the derivation looks like this. So you have a reactant A, okay, which is getting converted to the product. Okay, reactant A converting to the product. Now in this case, how will you write the rate equation? Rate is equal to, correct? Rate is equal to minus of dA by dt. Now why minus is coming? Because it is a reactant, its concentration keep on decreasing. Now we know that this rate is equal to what? Rate constant into the concentration of A. Here only the difference is coming, raised to the power 1. We don't want to mention it 1 here because normally if nothing is mentioned it is 1. Okay, in zeroth order what we will do here, we will keep it as 0 so that the whole term will become 1. So since it is first order, I am keeping it as 1. Okay. Now how I can write now? I can say minus dA by dt is equal to K times concentration of A. Now what we can do here is, we can, now this is an equation actually. Now we use in maths, there is a method called variable separable method. This is a differential equation. So we can group the similar terms. Here dA means it is the differentiation with respect to A, and the term is here A is present on the RHS. We can take that here, and K is a constant, so dt can be brought here. Okay, this method in maths is called variable separable. Okay, so we are rearranging, we can say on rearranging, this will becomes minus dA by concentration of A, okay, equal to K times D into T, dt. I hope this much is clear for you. Now what we can do is, we can do the integration. So when integration, the question comes here is from what time interval? So I can say from initial time interval to the time that we needed. Okay, so let me rub this. Okay. Yeah, so here I can say integrating on both sides, integrating on both sides, integrating on both sides, so we can say minus of, or I can take the minus here also, that is also fine. So 1 by concentration of A dA is equal to minus of K into dt. K is a constant, you can take outside. Now the most important question here is, what is the limit you apply? So I can say, let me say with respect to A, at time t is equal to 0, the concentration is A0. And at time t, we say the concentration is A of t. Okay, so similarly here at time t, since it's a variable time, I can say 0, and after a time t, it becomes t. Understood? So A of 0 denotes what? Concentration at time t is equal to 0, and A of t denotes the concentration at a particular time t. Here right hand side completely time is the variable, so initial time is 0 and final time is t. I hope you understood the concept. Now I can say here that I can mention it very clearly here. Listen, when t is equal to 0, when t is equal to 0, what is the concentration? Tell me, the concentration A is A0. Okay, and similarly when time t is equal to t, after a time, what is the concentration? A is equal to, it becomes A of t. So this is the understanding. Now we can can integrate this. So tell me, what is integral of 1 by x dx? You might have learned this. So integral of 1 by x dx is equal to log x, ln x. This you need to learn from the maths. You need to take it from there. So students might have learned, some might not have learned. If you don't know this, just learn. Integral of 1 by x dx is equal to log x, ln x. Okay, natural log. So here tell me 1 by a dA. Similar to that, what will be that? Ln a. Then what you need to do? Apply the lower limit and upper limit. A of 0 and a of t. Now similarly, do the integration here. What is integral of dx? If nothing is there, what is integral of dx? So we know that on integrating a constant, we have a formula x raised to n plus 1 by n plus 1. Correct? So what you need to do, put n is equal to, here nothing is there. So n is equal to 0 means it will become x raised to 0 plus 1 by 0 plus 1. That is x. Understood? So here I can say integral of dx is actually what? X. This you need to again take it from the maths. I cannot do anything outside this. This is a formula you need to remember actually. So here now tell me what is now integral of d. So here I am taking the constant outside. So minus k. Now integral of dt will be what? It will be, as I told, that variable t. Integral of dx is x. Similarly, integral of dy is what? Y. Okay. So t. Then apply the lower limit and apply limit 0 to t. Clear? So if you need more understanding, let me try to give you some explanation so that you will get an idea. So let me say integral of x raised to n dx will be x raised to n plus 1 by n plus 1 plus integration constant. Now here in our case, there is only dx is there. If dx is only there means n should be what actually? N should be 0. So I can write like x raised to 0 dx is the question. So what will be the answer? Apply this in this formula. X raised to 0 plus 1 by 0 plus 1. You will get x. That's how I told integral of dx. This is what actually x raised to 0 dx is integral of dx. That is how integral of dx is becoming x. Understood? Okay. This is for those students who doesn't know the integration. So this formula you need to remember. There is no other go. That is integral of x raised to n dx is what? X raised to n plus 1 divided by n plus 1. And similarly, differentiation is also there. Can anybody tell what is differential of x raised to n? All these things you need to learn in maths or physics. X raised to n dx. Integration. Answer is n into x raised to n minus 1. This is in differentiation. If you differentiate an x raised to n, this will become n into x raised to n minus 1. If you integrate it, it will become x raised to n plus 1 divided by n plus 1. Okay, so I hope you got a fair idea. Now I hope you understood how the t is coming here. Correct? Okay, so up to now we have done up to this point. So k I have taken outside minus k. Then integral of dt 0 to t becomes t. 0 to t is the limit. Now apply the limits. On applying, first apply the upper limit, then apply the lower limit. So upper limit minus lower limit. So how this will become? ln, listen, ln, upper limit I am applying it a of t, correct, minus lower limit ln a of 0 is equal to minus k into, apply the upper limit t, on substituting here t, applying the 0 here t minus 0. Okay, so this is how it becomes. Now what you need to do, you can rewrite the equation. Okay, so listen, so on rewriting the equation, this will become what actually? ln, okay, ln a of t minus ln a of 0 equal to minus k into t. So I can take the minus here. So what will happen here? I can write ln a of 0 minus ln a of t is equal to k into t. This is how I will get. Okay. Now again I can rewrite, because we know that log a minus log b is what actually log of a by b. You might have learned this in schools actually. So how I can write log ln a minus ln b. So how I can write here? So this will become ln a of 0 by a of t. Ln a of 0 by a of t is equal to kt. This is the equation you should remember. Suppose they are asking you the integrated rate equation for a first order reaction in a natural logarithm. Ln, natural log means this is the one. Suppose if you want to convert this into log format, what you need to do? How to convert ln to natural log? Natural log to normal log, multiply by 2.303. So what will happen here? I can write in other format 2.303 log a of 0 by a of t is equal to kt. So if they ask in this format, you should remember like this. Okay. Now from this, what is the equation? Okay, I can put this in red form. Please remember these two equations. Okay. Now from this, what is the rate constant k? How you can write rate constant k? Rate constant k is equal to, from here I can write rate constant k is equal to 2.303 log a0 by at log a0 by a of t divided by time t. So this also you should remember, because this will give you the rate constant k. So please remember the rate constant for a zero order reaction and first order reaction. 2.303 by t log a0 by at. Clear? So I hope this is clear for you until now. Now let's try to see the various graphs involved in this derivation. Okay. So next we will try to see the derivation of log a of t versus t for a first order reaction. So I will mention here, this is for a first order reaction. First order reaction. Okay. First order reaction. Okay. Now can you tell me the equation? We have learned that the equation was log a of 0 minus log a of t. Log a of 0 minus log a of t is equal to k into t by 2.303. I hope you remember. I have taken 2.303 over here. Correct? Now what we need to do, log a of t versus we need to take. So what I can do, I can multiply by, I can take log a of t to the RHS. So this will become what actually? Log a of 0 minus k into t by 2.303 is equal to log a of t. Okay. So based on this, I can try to derive my graph. Now here also if you see, I can say this also looks like a straight line. This is my y, because log a of t as the time varies, this will be varying factor. Y is equal to, this is a log a0. A0 indicates the initial concentration. So this is a constant, this won't change. So this is a constant c, and this is, if you see, this is a variable, time is a variable, and you can see 2.303, it's a constant. So I can say mx, this is y is equal to minus mx plus c. This equation looks like. So I can properly write this, okay, for your understanding. So I can rewrite this as log at, log concentration of at is equal to minus kt by 2.303 plus log a naught. Correct? So if you see here, this is y, this is minus mx, correct? Because this k by 2.303, is a variable. No, is a constant, and t is a variable. So x is t actually, and m, that is the slope, is what actually now you could understand, k by 2.303. This is a repeated question for first order integrate, for first order reaction. What is the slope? So slope is what? K by 2.303. Sorry, minus k by 2.303. Correct? So I can say y is equal to mx plus c. Now if m is here, what actually? Now tell me, on comparing this equation, I can say m is equal to minus k divided by 2. So this is the slope. So please remember, for slope for a first order integrated rate equation is equal to m. On comparing this with our standard first order equation, I could understand this m is mx. So m should be what? Minus k by 2.303. So please remember, this is very important for exam. So I can write here, this is equal to the slope of a first order reaction. Now we will try to graph this. Now I will take only this equation and I will try to graph log a of t versus t. Okay, so I can rub this and we will try to draw the graph, how the graph looks like. And anyway, you know that since it's y is equal to mx plus c, it is a straight line. But we also know that here the slope is negative. So slope is negative means the straight line keeps on decreasing. So what is the expected graph? So if I plot log a of t here and time here, okay, this is log a of t and this is time t. Either what you can do is you can substitute different time values and calculate it, or else you can think it. Y is equal to mx plus c. It is a straight line. Usually it will increase, but here the slope is negative. Slope you can see minus k by 2.303. So it will be initially having some fixed value. Thereafter the slope keeps on decreasing. So I can say this is the initial fixed value at when time t is equal to 0. And time t is equal to 0, what is happening? This whole term will become 0. And only the log a of 0 is there. So I can say this is what actually log a naught, initial concentration. Correct? Then thereafter what is happening? The time will become 1, 2. So based on that, this factor will get decreased from this. So it keeps on decreasing. Correct? Since it is a straight line, this decrease will be linear in nature. So this is the slope. I hope you understood. Clear? So very simple, put time t is equal to 0, so this factor will disappear. I know that at time t is equal to 0, what is the initial concentration? Log a naught. Thereafter put time t is equal to 1, then this value minus this value, so it will be less than, so it keeps on decreasing. And I know that since it forms the line, it has a resemblance with the straight line equation, this decrease will be linear or straight line in nature. So I hope this is the graph, and please remember the slope of the first order integrated rate equation, that is minus k by 2.303. Please remember, very important. Okay. So next we will try to see the exponential form of the first order reaction. Okay. So as I told, we will just see the exponential form of the first order reaction. The exponential form is very simple. So we can say a of t. Actually, this is derived from the other one itself. When you take the log to the other side, it becomes exponential e. So a of t is equal to a of 0 into e power minus k of t, where k represents the rate constant, t represents the time, a0 represents the initial concentration, and a of t is the concentration at particular time t. Now, how will you form the graph for this one? So if I draw a graph between a of t versus time. Now tell me what I can do. I can put initially time t is equal to 0. When it becomes 0, you will get a of 0 as the initial value. So let me say this is my a of 0. Okay. Now I am putting time t is equal to 1. Then it should be multiplied by e raised to minus k. Correct? So when you multiply a value with the e raised to minus factor, that keeps on decreasing because it is minus of that factor. Correct? E raised to minus k means what actually? 1 by e raised to k. So 1 by e raised to k into a naught. That means this is divided by this value. So that will be lower value. So I can say that this A0 will keep on decreasing in an exponential way, because it has exponential E factor, but it is not increasing, it is decreasing. Understood? So this is the integrated, you can say, the rate equation for a first order reaction in the exponential format, and the graph A of t versus time looks like this. It keeps on decreasing in an exponential way. Clear? Now next we will try to see the half-life of a first order reaction. So coming to the half-life, you know that what is basically half-life? I have told in the 0th order reaction. So half-life is the time required for a reaction, correct? It is a time required for a reaction for the initial concentration to become half of the initial value, correct? So I can give that heading. So half-life of a first order reaction. So half-life of a first order reaction. Now tell me, at half-life what will happen? I can write at time becoming t half, correct? Half-life means half of that particular time where the initial concentration becomes half of the initial value. So what will happen to the initial concentration? So we can say A of t will become what? A of 0. What was the initial concentration? It is half. A of 0 by 2. Correct? So at time t is equal to t half. T half is that time which is required for the reactants to become half of the initial concentration. Okay, now we will try to derive the value of t half for a first order reaction. So first order reaction, what is the basic equation? We know that K is equal to 2.303 by T log A of 0 by 80. Correct? Just now we have derived it. Now apply the T half condition. On applying the T half condition, what will happen? K is equal to 2.303 by T becomes what on applying T half? This becomes T half. Now log, what will happen to A naught? A naught is a fixed value, so it will be A naught divided by what happens to AT? AT is the concentration at particular time T. So here AT is the concentration at T half. So at T half, at time T is equal to T half, AT is equal to A naught by 2. So I can write A naught by 2. So this will get cancels off. So this can be further written as T half is equal to 2.303 by K. I have taken this here and K over here. Log 2. So what is log 2 basically? 0.3, around 0.3. So what this value will become? I can summarize the value as T half is equal to 0.693 by K. So how that is coming? Log 2 is equal to 0.3 approximately. So 0.3 into 2.303. So that will become, correct? 0.2 into 0.3, that is 0.6. So 0.693 by K. So please remember this equation. So T half for a first order reaction, the equation T half is equal to 0.693 by K. The most important thing is T half is not depending upon any initial concentration for a first order reaction. Understood? So this is very important, these derivations and all. You need to learn it in the school. Also you need to remember these equations for entrance point of view. I hope this is clear. Now we will also try to see a graph actually. T half versus A of t. Okay, so let me say how the graph may looks like. So I am rubbing these things. Okay, so I have rubbed all these things. So let me say how the T half graph looks like. So this is T half. Okay, and this is the concentration. And I know that for a first order reaction, T half does not depend upon the initial concentration. If you look at the equation, you can see that T half does not have any dependency on A naught. So what is that means? Whether A naught, if you are increasing or decreasing, T half will always remain the same. That is, it is a constant because it is always 0.693 by K. So that value will always be same. Okay, it is just deviating. It should be horizontal. Okay, that is, it is not changing while we are changing the initial concentration. So that means if you are taking the initial concentration as high or less or whatever be, the value of T half will always remain the same. For what order equation? For a first order reaction. Hope this is clear for you. If you have any doubt, please come back to us in the doubt clearance session. Thank you. Now next we will try to see some problems. Okay, so we have our first question in front of you. It's very easy question as a starting. Okay. So question here is the T half of a first order reaction is given as 6 minutes. Calculate the rate constant of the reaction. So we know that T half for a first order reaction, what is the equation? So we know that T half for a first order reaction is 0.693 divided by K. So in this question they are asking you to find out K. So what is K here? So K can be written as 0.693 divided by T half, correct? So 0.693 divided by, what is T half? They have given in minutes, 6 minutes. Okay, so if you are doing it in minutes, you need to say the rate constant K is per minute, you need to say. But if it is in second, you can convert this 6 minutes. 1 minute is 60 seconds. So 6 into 60, 360. But you need to see the options in which way they have given. Okay, so I am substituting directly in minutes. So if you calculate this, this will become 0.1155 approximately. 1155 minute raised to minus 1. So this is the value of the rate constant K. I hope it is clear for you. You will try to see the next problem. So we have a new question in front of you. Just go through it. A first order reaction has a specific reaction rate of 10 power minus 3 second raised to minus 1. How much time will it take for 10 gram of the reactant to reduce to 2.5 gram? This is the question. So they are clearly saying it's a first order reaction. So first order reaction means what is the rate equation? We know that rate constant K is equal to 2.303 by T log A naught by AT. Correct? Just now we have learned. Now tell me, they are telling it has a specific reaction rate. What do you mean by specific reaction rate? It is the other name of rate constant K. So in question sometimes they say it's a rate constant or sometimes they say specific reaction rate. So the rate constant K they have given as 10 power minus 3. 2.303. Now they are asking you how much time. So time is what you need to find out. For what? The initial concentration was 10 gram. Correct? To reduce that to 2.5 gram. So if you divide the cut it, it will become log 4. So how I can rearrange it and write T is equal to 2.303 divided by 10 power minus 3 into log 4. Correct? So what is log 4? I can write it as log 2 square. So this will become 2.303 by 10 power minus 3 log 2 square. So that is nothing but I can write it as 2.303 into 10 power 3 into 2 log 2. Correct? So tell me what can be the approximate value. This I am multiplying. So this will become 2303 into 2 into log 2 is 0.3. So just multiply it and tell me how much value you are getting. So 2.2303 into 2 into 2 into 0.3. So this will come around 1386 second. So if you multiply that, you will get it as 1386 second. I hope you understood how we have gone through the problem. So similar problems you can expect for Neet. Okay. So next we will try to see the nth order nth order integrated equation for an nth order reaction, and you will also see more problems. These are all simple fundamental problems. We will do important problems or tough problems in the coming sessions. So this is just a stepping stone, just to understand this is how we need to approach. Okay, thank you.